Hi everyone. So the original audience that this talk was intended for are people who might have never seen Haskell before, or thought about why it's interesting. So I'm not sure how much you'll get out of it, but hopefully you'll find at least some of this interesting. And it's not just Haskell. So today I'm going to talk to you about typed holes. So what's a typed hole? A typed hole is a placeholder for an expression with whose type we know, we can find out, but whose value we don't know exactly. So we don't actually know what should go there, but we know the type of the thing that should go there. Why do we like type holes? Because they allow the programming language to help us write programs. So what does this mean in practice? And why do holes need to be typed anyway? So let's write a program in Python to demonstrate. So I'm going to try to write the map function in Python. I want to take a function and a list and apply the function to each element of the list. So I do that, right? It works? No? What about this one? So the interesting thing is that I know this is wrong, you know this is wrong, just looking at it, right? But does Python know that it is wrong? Maybe, but probably not. But does it care? That's the real problem. It doesn't. So what about this one? So I do this. I read up on list comprehensions, which are apparently the way that you do things with lists in Python. So I do that, but I forget to put a return statement in. So now that I've pointed that out, you know that it's wrong. I know that it's wrong, but does Python know that it is wrong? It doesn't. So I get really frustrated at this point. I look into how the built-in list comprehensions are implemented. So I add a return statement in, like I'm supposed to, and I use I think generator comprehensions. I forget what they're called, but basically I swap out my square brackets for parentheses. So I do that, and instead of getting a useful value, I get a string representation of a location in memory. This is particularly useless, right? What am I supposed to do with this? So how do I write programs that work? And this seems quite silly, but literally, I've been writing Python for over a decade, and I would run into issues like this all the time. So I asked a lot of people because I'm so frustrated. I need to know. And what they'd say is, look, you need to write a test. You need to write lots and lots of tests. I'm like, okay, that sounds reasonable. So I write a test, and I write a map function to go with my test. And it passes, and everything's good forever. So tests aren't good enough, right? Because, well, for a couple of reasons. So, but the thing about tests that I hate the most is that the language doesn't actually understand tests. So suppose I write a test and the test fails. It doesn't tell me where I'm supposed to fix my code. It just tells me false. And if I write a test and if I write a test and it passes, it doesn't actually give me all the assurance that I want that that my program is correct. So tests are a specification. And they're only as good, your specification is only as good as the strength, as how many tests you have or how much of the possible space of inputs your tests cover. Fortunately, tests aren't the only specification. Types are a specification. And the language does understand types. If I write a type and a program and they don't match each other, the language can at least tell me which area of the code I should focus my attention. I think that's how Simon put it yesterday, right? Attention localizing device. That's what a type system is. So what does this mean in practice? Enter Haskell. So Haskell is statically typed, but this is nothing special. Lots of languages are statically typed. What is special about Haskell, though, is that Haskell has really good type inference, which means I don't need to annotate the program with all of the types up front. It can figure out most of them for me. And if I take static types and type annotation and I put them together, I get typed holes. So what does this mean in practice? Wow, this is massive. This is much bigger than I expected. So instead, I'm going to decrease the size of my fonts. Apologies. There you go. Oh, thank you. Computers. OK, so this seems to kind of work. So I'm just going to, all right. So, yep. Right. So I have a program, and I have an error. And this is the typed hole, so the underscore here. So if you ignore the middle, I find the middle of these things not very useful most of the time. But so just focus on the top and the bottom. So the top tells me that the thing that's supposed to go on the underscore is a value of type list of B. So the only thing that it seems I can do here is pattern match on the list. So if I do case ls of, so a list can be either an empty list, so that's hole number 1, or it can be a head attached to a tail. So that's hole number 2. Do that. I have 2 typed holes. They're both of type list of B. So, but given an empty list, the only reasonable thing that I can return is another empty list. So do that. And if I, yes, I do that. And if I take a list apart into its head and its tail, it makes sense that I need to put something back together. So I need to use the cons on the right-hand side as well. So do that, again, 2 typed holes. Now the first typed hole is more interesting. So it's a value of list of b. And looking at this output, I can see that I can take my f, and I can apply it to my x. So then I get a value of type b. And like the only reasonable thing I can do here is I recurse. So I use my map, I use my f, and I use my x's. So I do that. And it compiles. It's great. But does it work? It does. Excellent. So this is great, but I feel like this isn't quite what I want because it's very, very easy to break this program. Let me show you my favorite way. My favorite way is what happens if you replace the effective case with nothing. It's still all good. So what's going on here? So it turns out that an empty list is a valid list of any type. Is it a list of integers? Yes. Is it a list of strings? Sure. So this isn't quite right. This isn't quite what I want. So I've gotten some of the way there, but not all of the way there. So can we do better? And the answer is yes, of course we can do better. Enter Idris. So Idris is a programming language with a more sophisticated type system than Haskell's. Fortunately, it also has weaker type inference. So it's not, it's not absolutely like better in every way. Although it does have better editor integration. And what this means is we get fancier typed holes. So what does that mean? So maybe if I, yeah, okay. So I have this program open. I'm going to show you my keystrokes so you can see what's going on. So I've implemented, so the major difference between this program and my Haskell program is that I have length indexed lists. So they're called vecs in Idris, and I can either have a vect of length 0, or like my cons, which is now a 2 colon instead of 1, takes an element and a list of some length, and it gives me a new length index list of length plus 1. So I've implemented equality on these just to make things a bit easier, so because I use it in my test. And I can look at the type of my map function, so I can do leader t, give me a type. But I can also go ahead and just define a skeleton, so fill in a skeleton definition. So it just does that, so that's cool. And then I can, again, look at the type of my typed hole with leader t, so it shows me that. But I can just go ahead and case split. So the leader C is for case split, so it splits up my list into the head and the, so sorry, the list, the case where it's an empty list and the case where it's a head and a tail. And it just does a really cool thing called a proof search. You can do a thing in Idris called a proof search. So it searches the space of all possible programs and picks the first one that fits. So I can do leader O for obvious, and it fills it in. And I can do, so that works in the simple case, but it doesn't work in the more complex case. So I do that again, and great, it does work. So I can reload my program. Yep, so I can execute the main function. So I'm just going to turn off my keystrokes again. OK, so that works. So what happens if I try to break this program, the same way that I broke my Python program, sorry, my Haskell program? Do that, reload. Sorry, I'm just going to, yeah. OK, so now I get an interesting error. So what it tells me is that instead of giving it vector of length plus 1 of some other vector, I'm giving it an empty vector. So I failed to pull the wool over Idris's eyes. So it's good, so everything works. Yep, great. So the important thing to note here is that we did it. So typed holes, if you haven't used them before, and I hope most of you have, they exist. And you can download these languages and play with them like right this instant. It's nothing stopping you. And when I worked in other programming languages, I was used to kind of thinking of, like, even statically typed languages, thinking of like types as this thing that you basically had to like feed the compiler, like shove down the compiler's throat in order to get it to accept the program that you're writing. But that's not all that types can be. They can help you design your program, they can help you write your program and debug your program. And programming doesn't have to be like a sequence of just making errors over and over and over again until it like passes through your compiler and like you still don't know if it's right. It can be fun and interesting. It can be an interactive thing, exploration with your compiler. So a lot of this material was taken from actually probably the least interesting part of Connor McBride's talk that he gave at, I think he gave it at HaskellX 2 years ago. What is a type left by a lamp. And there's more tutorials. And thank you. But before I let you go, I want to talk about untyped holes. So what if you like the idea of holes, but you don't like the idea of types? So some people are like that. What they do is that what you could do is you could write a program that has gaps in it, call it a sketch because it's a rough program, and you can write some test cases that basically satisfy the behavior, of the behavior that your program is expected to satisfy. You can feed both these things to an SAT or SMT solver, which is a very clever program with a bag of tricks. It'll search the space of all possible programs and churn and churn and give you a program. And this sounds amazing, right? What's the catch? Catch is that it's still a research topic for now, unfortunately. But here's some resources. In fact, there's a couple of resources that I haven't listed here. But I'm told that Nadia, I think, gave a presentation at ICFP about Synquid recently. And there's also Hazel, which is like an interactive environment with typed holes, and a bunch of like other cool stuff. And this is a really interesting area of research. And I think it's really interesting because, especially Synquid, because even though it has a, I think, a more sophisticated type system than Haskell's. And so I'm not sure if it's dependent types or something else. But it has the idea of both. So you can do both sketches and typed holes. And I think that would be really, really powerful. And then we can like finally get to a point where like I don't actually have to write any programs anymore. It can just be like, just get the computer to write it for me, which is kind of its job. So yeah, I'm done. Thank you. Which one? So it's with this one or?
No, the one, not the Idris one, the Haskell one.
Yep.
Sorry. Keep going back.
Yep. Just give me a sec. Yep. All right. So this one?
Yeah, and make it do the type error thing, like where you just had the whole kind of thing.
Which?
That one. Yeah, that example. Yes, that one. Sorry.
Oh, so like this one?
Yep. Yeah. And you're really quick to show. It's like, oh, I just picked this and this and this. I'm curious. You were skipping over a couple lines there, and I don't. I'd be curious.
Oh yeah, right. So this is what I said in the beginning. Like I find that when looking at this output, it's not really useful to focus on the middle. I usually try to focus on like right at the top and right at the bottom. The value substitution stuff is, I think, relatively new. It's new in like 8.4 and 8.6. So I kind of like focus here and here. So here you can see that since I want something of type B, the way that I can get that is by taking an F and applying it to an X, right? And as you've astutely as you recognized, this is the part where it gets a bit hairy because the types don't really tell me like everything that I want to know. So I could put empty here or undefined, and it'll compile. But I say the reasonable thing to do here is to kind of consume the rest of your input, which is use x's somehow. So that's here. So you need to use f on x's because that's the function that we're applying to. And you need to use map. But the only way to get all of that to fit, so let's see if I can kind of go a bit further. And so I use a whole and then and then I go map of f and x's. So do that. OK. A b to b. So again, there's a whole bunch of things that could go here. But well, it is one thing. So yay. OK. So it's one of those things. Like you can't just mindlessly kind of go through everything. You still have to use your brain, which is something that I don't like. I would like to not use my brain at all. But it's pretty good. Yeah. Yes, Nikki. That's a good question. You could use vectors in Haskell. That's probably worth pointing out, that you can, in fact, get a length index list in Haskell. But my point is that this isn't something that most people reach for when they're trying to implement this, especially if you're relatively new to Haskell. You're not going to go, I know, I'm going to use singletons. So.
I just want to make a small remark because I didn't know that this was implemented for a long time myself. So if you have class constraints or also equality constraints in scope in Haskell, then by default, it will not actually show them. Right?
Yeah, but there's a GHC flag or something.
So there is an option in GHC that says -f show hole constraints, which should really be enabled by default, which makes typed holes just so much more useful.
I think that's new in like 8.2. So even these things are like, they haven't been around for that long. Yes, but it's there.
You can
yes, you're right.
It and it's really helpful.
Yeah, f show hole constraints. Is that what it's called? Yeah. Okay. Yeah, I've heard of this. But.
I think that's up. We're out of time, but thanks again, V. A great job.